Okay, can somebody walk us through how do we find the median of a set? Caleb, go ahead.
So you put the numbers in numeric from least to greatest order.
Correct. You place the data in numerical order from least to greatest. Okay, could you go ahead and take care of Denver for me?
Okay, so 29 goes first.
Okay.
It's 30.
Okay.
Then 33.
Okay.
Then 38.
Uh-huh.
Then 40.
Okay.
48.
Okay, keep going.
57.
What was next?
51.
Okay. Keep going.
57.
Mm-hmm.
62. 68. 72. 73.
Do you guys agree? You got that? Okay, so let me go ahead. Okay, I'm going to shrink this down so we can fit it all on one line. Can you guys see that okay? My writing? Okay. I want the median for both sets, right? Can you guys can I get somebody to volunteer to do the median for Miami also? Let's arrange Miami's from least to greatest. Okay. Glorabel, can you go ahead and do that? Uh-huh. 68. Go ahead. Uh-huh. Hold on a second. 79, and you said 80. 82. 82 again. 84. And 84. That's it? Okay, and they're 12 months, right? So we should have 12 in each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let me shrink this down so we get these to fit. Okay, so when we find the median, what are we doing? How do we find the median? Yes?
So you isolate everything else but the middle numbers, so you will cross out all the outside numbers.
Okay, very good. So we need to find the middle number. And on an even set, are we going to have a middle number?
No.
Okay, we have 12 data points for each for Denver, 12 for Miami. And so because it's even, we're not going to have a median. We're going to have to make a median. We're not going to have a middle number. We're going to make a middle number. So let's go ahead and do that. So we're going to isolate. I like how you use that. We're going to isolate our numbers closest to the middle. And do you remember how I described a method for doing that? Go ahead.
So when you cross out a number on the left, you also cross out a number on the right.
Right, so we'll cross out a number on the left, and we'll cross one out on the right. And notice how we're going to use a backslash and a forward slash to see where they meet up. Okay, and they meet up at 48 and 51. Okay, now what's the next thing we got to do? Go ahead.
You have to add those numbers and divide by 2.
And what are we doing when we add the two numbers and divide by 2? What are we doing to? We're finding the mean of those two numbers, right? Very good. So we're going to take 48 plus 51, and we're going to divide that by 2. And what is 48 plus 51? 99. And what's 99 divided by 2?
49.5.
Well, hold on. 99 is almost 100, right?
Yes.
What's half of 100?
50.
50, right? But it's one less than that, right? So what's it going to be? 49 and 5/10. Isn't 49.5 plus 49.5, isn't that going to be, right? So let's go ahead and do that for the one next to it. That was Denver. Let's go ahead and take care of Miami. Same deal. Slash. Did everybody get that for an answer? Okay. Let's figure out where my middle number is. Here are my two middle numbers. So 76 and 79, is that what everybody got? So if I take that, I'm going to find the average of 76 and 79. I'm going to add them. Divide them by 2. What's 76 plus 79? What is it? 155 divided by 2. And what is 155 divided by 2? 77 and 5 tenths. 77 and 5 tenths. So we have our medians. You guys agree? We're good? Okay. The range. Does anybody have a desire to explain to the class, how do we find the range? How do we find the range? Uche, go ahead.
So to find the range, you have to subtract the largest number from the smallest number of the data set.
Very good. So we're going to take the largest, we're going to subtract the smallest. So for Denver, what's the largest going to be? 73. And what's the smallest value? 29. We're going to take the difference of those two, right? And then what'd you get?
24.
Very good. And then what was the largest number for Miami?
84.
And then you took away what? And what'd you get? 16. Everybody with me so far on what we're doing? This is all review from Friday. Okay, and then the last question, who could answer the mode? Who can tell me about mode? Mode. Fatima. For Denver, what's the mode for Denver? There's no mode. Why is there no mode? None of the numbers repeat. And what about Miami? Who's got the mode for Miami? Somebody I haven't heard from yet. What's your name, young man?
Ola.
Ola, what is it?
84
84
and
and 82, correct. Okay, any questions about this? Are we good? I'm going to go back and forth to this warm-up for the lesson for today because we're going to do box and whisker plots. So, can I get somebody to read the objectives and the keywords and then graphing to show distribution? Name? Timothy, could you go ahead?
Objective. Construct an integrate box and whisker plots. Keyword. Box and whisker plot. Lower quartile, middle quartile, upper quartile. Graphing to show distribution. One is writing about the climate of the United States for a science project. As part of his research, he finds data on the mean daily temperatures in the two U.S. cities, Denver and Miami. The data amounts are in the table below.
Okay, so does this look familiar to you, the data right here? Does that data look familiar to you? It's the warm-up, right. So I wanted to save some time. And get us started. So we're using the data that Juan collected, mean daily temperatures. Juan wants to create a graph of the data that's going to show the median and the range of the temperatures and how they're distributed, okay? The type of graph that accomplishes this goal is the type of graph we're going to review today, box and whisker plots, okay? So let's go ahead, fast forward, and talk about this. So using box and whisker plots to show distribution, could I get somebody to read through this port right here? And it's the same data. Christian.
Using a box and whisker plots to show distribution. A box and whisker plot uses the number line to divide data into sections that show how the data are distributed. The median divides the data into two equal sections. These sections can be divided using quartiles. The lower quartile is the median of the bottom half of the data. The upper quartile is the median of the top half of the data. You can use the information from the table to construct a box-and-whisker plot of the median daily temperatures from Denver.
Okay, so I have a number line here. I'm going to go back to the warm-up, and I'm going to copy that data that we have, okay? So this data that we have from earlier, let me go ahead and copy it. Make sure I got it all. I think I got it all. Okay, let's fast forward to that slide. Right here. Okay, so remember the data from earlier? So we're going to use that right here. And notice we have our number line, right? And our number line includes the range of data, okay? So first thing we need to do is find our median, right? But now we have this median, and that median sits right here. This number right here is the median, and it sits right here in between 48 and 51. And then you can also guess that for Miami, this median sits right here, okay? That's the median for Miami. Now, the median has another name. It's the middle quartile, okay? Now, I want you guys to think about something really quickly. Who likes eating candy bars? Okay. Have you guys ever had to share something in your life with a cousin, a brother, a sister, or something like that? Okay, everybody here has to share, and that's a hard lesson for everybody. But if you ever have to share with somebody else, or if you ever have to, has anybody ever had a babysitter watch somebody? Okay, have you ever had to get those kids to share? Okay, when it comes to food, this is how I always handle it. I said, look, here's this candy bar. The two of you can split this, but here's the rules. I'm going to let you cut it in half, and I'm going to let you pick it. Does that make sense? Why do you think I do it that way? Yes, Olamide. Well, the person that cuts it in half is going to want to make sure it's as equal as possible, right?
No.
Why wouldn't they want to? Because the other person is going to pick it.
Because
If he or she doesn't make it equal, the other person is going to pick it. They're going to pick the bigger piece, right? So let's not dwell on this too much. Let's talk about this candy bar really quickly. And there's a reason for this story. So if I have a candy bar and we make a slice right down the middle, how much do I have? This side is what? Half, right? So this is half, and then this other side is half, right? But suppose I had to split it into 4 equal parts. Can somebody explain the process of splitting it into 4 equal parts? Logan.
Well, you cut it in half first, and then you take half of the
Nice. So I cut it in half, and then I take half of the halves. Did you guys understand what she said? So if I take half of this half, how much is that?
1/4.
Well,
A quarter.
this is 1/4. And now I have over here 1/4, right? And then I have the other half to cut into half. And so if I cut the other half in half, this is 1/4. and this is a fourth, right? Okay, now let me bring you guys back to what we're covering, which is quartiles. How many quarters in a dollar? There's a reason. A fourth, a quarter. If you look, this is a fourth, a quarter of my candy bar, right? This is a quarter of my candy bar, this is a quarter of my candy bar, this is a quarter of my candy bar. Now, if we think about my data like candy, like a candy bar, my median made it into two equal data sets. Do you guys understand? So that's my middle cut or my middle quartile. Do you guys understand? Now, I have to split the first half of my data into two equal parts. Do you guys understand? So let's go ahead and do that. Oops. Now, I'm going to use a different color on the top. So remember I made that cut of the first half, so I get my quarters? I'm going to find what's called my first quartile. So this split right here is like my first quartile, right? My first quarter. Do you guys understand why the name's quartile, quarter of the data? Got it? Got it? Okay, that's why I went off on that tangent about the candy bar, but now you're going to have a story to go with quartiles. You're going to remember it. So I need to split this part into halves. I don't consider this number. I look at just this part of the data. Okay? Is that first half, is that even or odd? Okay, so are we going to have to make another cut, or is the median of the first half going to be in there? We got to make it. So let's keep track of it. And I'm using a different color now, right? So boom, 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 boom. And I have these three numbers in the middle, right? So we need to find the median. So I got to do what with those two numbers? Add them and then what? Add them and divide by 2. So can you guys really quickly do that? So 33. And let's try not to call out. I would like for you guys to do this on your own in your notes. Write it down. Work it out. Have this in your notes because you guys are going to have to take a practice test tomorrow. I'm going to let you use your notes for that, but have your notes. So 33, 38, and then we divide that by 2. And then I'd like a volunteer to share the answer with me. Somebody that's not calling out, somebody knows how to raise their hand, somebody who's written it out in their notes. So Carter, I haven't heard from you today. What's the first quartile or the lower quartile going to be? So we're finding that by taking the median of the lower half of my data. So we just figured out what the middle two numbers are, but that's not the lower quartile. Can you tell me what it is? So when you added these together, what'd you get? 33 and 38, 71. And then you got to divide that by 2. And what's that give me when we divide that by 2? Well, what's half of 70? Okay, what's half of 1? Right, 31, 30, 35, and then 0.5, right? Okay. Okay, that's my first quartile. Now I got to figure out my lower quartile. Now I got to figure out my upper quartile. So the same thing I did with the first half, I got to do with the second half of the data. You guys understand? So now I got to, it's on like on the candy bar over here. Now I got to cut the other half of the candy bar. Do you guys understand? Okay, so we got to look at these over here. I'll use a different color this time. This time I'll use, okay? So boom, 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 boom. Now I got these two in the middle, 62 and 68. So you guys really quickly do that on your own. Please don't call out. Write it out. Work it out on your paper. Write it out. Work it out on your paper. Okay. Joseph, can you share with the class what'd you get? right? 60 and 60 is 120, and then 2 and 8 is 10. So 120 plus 10, 130. Divide by 2. And what's 130 divided by 2? What's half of that? 65. Okay, so guess what we got? We have everything we need for our box-whisker plot for Denver. So we're going to make our box-whisker plot for Denver. Now, here are the points we gotta put on the number line. And I'm going to do this all in red since we wrote the numbers down in red for Denver. So first of all, what's the smallest? Oops. I need a different number line. Let me make one for Denver. And I'll put this one down below. So we'll use that one for Miami. And I'm going to make a different one for Denver. We're short on time, so I'm going to... Okay, so what's our smallest value? 29. Let me go ahead and make a number line. This is just a rough sketch. So it starts at 29 and it ends at 73. So this is how you'd have to make your number line. So 29 is pretty close to 25 and 73. So I'll start my number line at 25. And then let me just skip by 5. So 25, 30. This will be 35, 40. 45, 50, 55, 60, 65, 70, and then 75, and then I think we're good. Okay, so let me go ahead and graph this. And this is just a sketch. So my smallest value in my data set for Denver is what? 29. So I'm going to go ahead and graph that. This is 30, so it's going to be a little bit smaller than that. And above, I'm just going to make a line above where that is about. That's almost 30, right? So you guys see how I almost put it to 30? Okay. Now, the greatest value in the data is what? 73. So it's not going to be at 75. It's going to be a little less than 75. And I'll go ahead and label this just so you guys see. This is 73. And then over here, this is 29. Okay? Now, the lower quartile is how much? How much is the lower quartile? 35 and a half, 35.5. So it's just a tiny, tiny bit larger than 35. Okay? And then the median was what? We found the median. What was my median? Come on, we did this for a warm-up. 49 and a half, 49.5. So almost to 50. And here's 50 right here. Okay, now we got our upper quartile, and how much was that? 65 exactly. Now, let me show you how easy a box-whisker plot is. Do you guys understand where all these lines came from? Okay, this is the minimum. 29 is the minimum. 35.5, 35 and 5/10, that's the lower quartile. 49 and 5/10 is the inner quartile, or it's called the median, two names. Sometimes called the middle quartile, right, or the inner quartile. 65 is the upper quartile, okay, and then 73 is the maximum. Now this can be called the first quartile, second quartile, third quartile. I've heard it called that. I've heard this called the lower quartile. Okay, I've heard this called the middle quartile and the upper quartile. Okay, it has, just know the different names. We'll review that some more. But let me go ahead and draw my box-whisker plot. Watch this. For the quartiles, let's connect them. You see my box? Now let's make my whiskers. Pretty easy, right? You guys got it? Okay. What I want you to do, I want you to do Florida, or Miami, excuse me. Go ahead and get Miami done. On your own, do it. Get it done. Let's do Miami. Yes. Try. We'll talk about it. Try. We already did the middle quartile. You need to do the lower quartile and the upper quartile. You're using this data and doing the same thing we did with Denver, except for with mine. Did we mess up somewhere?
No, because there's nothing in for 82. There's nothing in between 82.
1, 2, 3, 4, 5, 6.
And the middle are 82, 82.
Oh, no, no, no. Look, if you make the median, so here's your upper, So listen, this is your lower half of the data. This is your upper half of the data. Got it?
Yeah, but 82 is in the middle.
What's that?
82 is in the middle.
So how would you find a median when 82 and 82 are in the middle? So just try.
Okay.
This is the try. This is not the no. This is the try. Try. Have you tried this yet? I need you to try. Take a guess. We're going to go over the answers in a little bit. Who's got the lower quartile? Walk me through it. And then here's the number line we're going to use to make our box-whisker plot. Okay, lower quartile. Walk me through it. Christian, go ahead. You had a lot of questions earlier. Did you figure it out?
Yeah.
Okay.
The low quartile, I crossed out I went from
Okay, you crossed out.
to the middle,
Okay, and what did you find in the middle?
70 and 72.
Right, because we go like this. Okay, and then we see these two in the middle. So let's go ahead and figure that out. What's that going to be? 70 plus 72 divided by 2, you're going to see is 142 divided by 2, and that equals what? 71. Okay. Who has the upper quartile? Thomas. I'm sorry, what? Yeah, what's the upper quartile going to be? What's the first thing you have to do? Okay, we're going to cross out the numbers because we're trying to find the median of the upper half. And what did you find in the middle? 82 and 82. And so what's 82 and 82, the average of those two numbers? Well, when you add 82 and 82, you get 164. And you divide that by 2, what do you get back? You get back 82.
That's what I was confused about.
Okay? So if all the numbers are the same and you average all the numbers that are the same, it'll just be the same number. If I added 82 plus 82 plus 82 plus 82 5 times and I divided by 5, it'd be 82. So the average of numbers that are the same number is just going to be the same number. Okay? So now let's go ahead and I'm going to put these down in green this time since this is Miami. What is the minimum value? Who's got the minimum value?
60.
No. What's the minimum value, the smallest number in the data set? 68. 68 is right about, this is 65, 6, 7, 8, 9, 70, 65. So right about here is 68. Oops. And I'm just going to label that so you guys know what I'm talking about. The lower quartile is what? Come on, we calculated. What is it? 71. So that's going to be right about here. The inner quartile, middle quartile, median is what? 77 and a half. 76, 77 and a half. That's right about here. Okay, the upper quartile, 82, 80, 81, 82, it's going to be right here. And then the maximum value, what is that? 84. There's 85, so that means this is 84. And now's the easy part. I make my box. And then I make my whiskers. Box-whisker plot. Are we good?
Yes.
Now sometimes they'll just have you put dots here and then draw the box. That's how I was taught. I like that way better, but you guys know how to read a box-whisker plot. Okay, even if you didn't have these numbers, you could look at this and say, hey, what's the median of the data? You just look at this, so the middle line, that's the median. Or if they ask you what's the third quartile, upper quartile, what's the third quartile, the upper quartile? 82. What's the minimum value? Do you guys see how you read one of these now? Okay. Now, here's what you're doing. That's homework. This is the homework assignment. There's a data table. You're going to make a box and whisker plot for the data table. Okay, they walk you through it. And then those are the exercises, but what you're going to go ahead and do, you can get started on this. Tonight for homework, there's 2 problems. It's to finish B. Go ahead and do A right now. And then the quick check. You have enough time to walk out of here and finish Team A's box whisker plot. Any questions? Pretty easy, right? Okay. Has anybody ever explained box whisker plots to you this way? Are you going to remember it? Are you going to remember the candy bar and quartiles? Okay. Well, if that's not going to help you remember it, find a way to remember it.